be a full something like three hour or 4 hours of lectures. No
Yes.
lab work today, so we are just going to talk. A lot of talking today.
Okay.
So do you have any question about what we did yesterday, or is it okay?
I'm not.
Did you have any question?
No. There's the other. I don't know.
And for the other, okay. So I'm going we are going to talk about containers with another type of visualization. After that, we are going to talk about um, um, I'm going to mix a lot of information today so that we can talk about many things. So today I think we could it will be interesting to talk about containers, which are now visualization solutions that are used um, most of the cloud by most of the cloud providers. We have containers in most of the cloud services today. We will talk about um, um, tools or software that can be used to manage private clouds. So we are going to talk about Kubernetes and OpenStack, and maybe we will talk. Maybe tomorrow we will talk about identity access management in the cloud and discuss a little bit about the security in the cloud before having our last lab work tomorrow, so that we can maybe not practice on the cloud, maybe manage a little bit of containers, do a little bit of operation on containers, maybe deploy Kubernetes, depending on the quickness you people are going to be depending on the rapidity you are going your rapidity to do the lab work. So today we are going to do a lot of talking. Yeah, it's going to be to have a lot of talking discussion. So let me project the slide. Do you have any question?
No.
Are you okay with today plan, or do you want to change something?
It's okay.
Okay, good. I'm always I'm always this is for you in case you have some guy who are very has a lot of experience in kernel developing. I'm looking for very good kernel developer, very system engineer, very good. If you know some students that are like that, that are capable of doing very kernel, developing kernel modules, operating
Hello.
systems, things like that, you can tell to your friend that you know someone which is interested by proposing a internship or even a PhD. So I'm seeking for some guy that can do such thing, because I have a project here and I need people to for the implementation. So if you have any contact, any guy you know that can do such thing, kernel implementation, system implementation, I'm really interested. Okay, so let me open the slide. Okay, so today we are going to talk a little bit about Docker. So we start by Docker. After Docker, we move to another topic. So the last time on yesterday, you people worked on a virtualization system, and you worked with Zen. So you installed Zen, you created a virtual machine on Zen, you, you were able to migrate Zen. You didn't do it, but try to do a demonstration. It was not perfect, but it kind of worked after a little bit of modification. So what you should remember is that visualization is the main technology used in cloud. So this is the visualization most of the time is the basic technology used in cloud computing. So if you are familiar with reading articles, scientific articles, if not, most of the contribution that when you have cloud computing, most of the contribution that are done in cloud um, use the hypothesis that you are running in a virtualized infrastructure, because you need the software to share your hardware amongst many clients. So when you are talking about virtualization, you have many types of virtualization. I will say we have a traditional, they have many approach of virtualization. I will say that you have what we call is called traditional virtualization. So traditional virtualization are the kind of virtualization we experiment yesterday with Zen, for example. That means you have a software which is the hypervisor which is used to virtualize to create an environment in which you can run operating system. So to create virtual machines. And now you have OS level virtualization, which is a relatively new type of virtualization. That means actually now you take your operating system, your standard operating system, and you extend this standard operating system in order to create environment that is isolated. I will say pseudo isolated. That means not fully isolated. So today you have a heavy virtualization, you have a light virtualization. With heavy virtualization, as in Zen, you have a strong isolation between operating system running in the virtual machine. But in light virtualization, like in the case of containers with Dockers, the isolation is not as strong as with heavy virtualization. That means the virtual machines or the containers, virtual containers and virtual machines share the same operating system as you are going to see. So this kind of light virtualization has the advantage of having very low overhead. It's very easy to deploy. It's very easy to orchestrate because as you notice, installing them is not so easy. And because I even simplify the procedure for you, I erase many things from a procedure for you to be able to deploy it during the lab work. But deploying such hypervisor sometimes can be very heavy. So with this lightweight virtualization, is simple to install. Virtual machine can start very fastly. The isolation is not very strong, but the performance are more interesting than heavy virtualization. So we are going to talk today about a we are going to discuss about a solution of this lightweight virtualization, which is Docker. So Docker is a okay. Let me. Ah, hello.
Yes, we're here.
I don't know why my slide are not. It's not scrolling. A minute, please. It's not scrolling. I don't know why. A minute. Docker. I'll share the thing. Okay. So now we are going to talk about Docker. So Docker is a solution to implement lightweight virtualization. So here you have it. So I will send you the slide, even the first slide, I will send it to you. I didn't forget to. So what is Docker? Generally, Docker is a visualization system that allow building what we call light virtual machines. So these are virtual machines with less isolation than standard virtual machines, as we did with them. So these virtual machines are known as containers. Have you ever heard of Docker or containers?
Yes.
Okay. Have you ever used this Docker thing?
No, not me, but others have.
Okay. So containers, they are very light virtual machines, um, less isolated than standard virtual machines, but they are still virtual machines. So the type of virtualization is OS level virtualization. So if you remember the figure, I told you that we have some operating system that have been extended to allow to have virtualization. So this is the case for Docker. So Docker is kind of a standard Linux kernel that have been extended with some functionality in order to create a pseudo-isolated environment, which are containers. So they are OS level virtualization. So they are very small VMs, they are very small virtual machines, and they have very few overheads. So that's the thing. So when you install Docker, for example, it comes with a very set of user-friendly tools. So you have a lot of tools that allow you to easily deploy an application in the containers, that allow you to easily orchestrate a cluster with containers. That means when I say orchestrate, that means deploy these containers on physical server. So Docker is quite easy, is quite nice in the context of continuous integration. Have you ever heard of continuous integration? Hello? Hello?
Yes.
Have you ever heard of continuous integration? Do you know what is continuous integration?
We continue.
Do you know what is continuous integration? Continuous integration. This thing. Continuous integration. Okay, so let me explain to you. So some of you already work in the company. So when you are working in the company, most of the time, those who are developers in these companies, what happens is that you sometimes have to implement. You participate to a big project, and you are in charge of implementing some part of this big project. So the project manager, so the guy who handles the project, he has to make sure that each he designed his huge project. He designed the architecture of his application, and he split his architecture into parts. And each team he will be responsible of implementing his part. But the final product will be the aggregation of the whole part implemented by each of the groups of the project. So the project manager, what he has to do is to make sure that every time a developer from a group commit or realize a change on the huge project, this will not, how can I say, this will not have bad impact on what was already working. That means if in the application, in the actual state of the application, there are some functionalities that are already been implemented and validated as working. If one developer from one group commits a changes, the application, the project manager must make sure that, or the technical leader of the project must make sure that by committing a changes, this will not disturb the good execution of what was already done. So in order to put to make sure that there's no hold back in the implementation of the application when there's a commit, what most of the tech leader do is that they put in place what we call a chain that consists on a chain of tests that before committing a change to the main application, you have to validate that by applying the change to the application. This will not make the application to move backwards. So you have to put in place a mechanism to test the application with the new commit without committing to the main branch of the application. So the process of testing the application, making sure that there's no holdback, and the new patch will not disturb all will not bring problem to the state of the application. This process of testing, making sure that there's no throwback, is called the continuous integration. That means the process of testing the application or the modification of the application during the development. That means you put in place a process for testing the application and to make sure that every time there's a change, there's not a holdback. So that's the thing. So you have this figure here like a pipe that corresponds to a continuous integration. That means you continuously integrate new changes, and you make sure that these changes doesn't move backwards the application. So you have to implement this kind of pipe. In this pipe, for example, you say, okay, every time there is a change, you add a change, you build, and you realize test on the application with the new changes to make sure that with this change, all the things that were validated in the application are still valid. You test, you deploy, you test again, and if everything is okay, now you can commit the change into the main branch and say, okay, with this modification, the application is still working well. So putting in place this pipe is what is called a continuous integration. But so in order to implement this, most of the time, you need you need to have an isolated environment where you can when you can deploy your application without having any impact on the main branch, add the modification and test it. And you can have this isolated environment. You can use containers to create this isolated environment. So for example, when you implement your application, I know that maybe during your 2 or 3 years in USTH, you have already implemented application in case in doing you already implemented application in the scope of project. So when you implement your application, for example, imagine most of the time when you implement your application, you start your Eclipse, I don't know, or your IntelliJ, and you start to write Java code, C++, C code, you write your application. But the day you want to test your application on your friend's machine, sometimes you have problem because maybe he doesn't have the same version of some library than you. Maybe he doesn't have the same version of the operating system than you, so it causes problem. So by using tools like containers, you can say, okay, every time I want to run my application, I will run my application in the containers, and the containers being an isolated environment, that will allow me to build this environment and setting the exact libraries and tools that are needed to run my application. So by packaging your application in the containers, you make your application to be possible to be easily moved from your um, computer to your friend computer, because every time your friend will want to maybe test your application, you just have to make sure that he has the containers with every tools and library needed to run your application. And by using containers, it creates an environment that is 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 clean for the application. But if not, you can have problem with libraries when you want to move the application from your computer to the other. So in general, by using containers, it allows you to create, in the case of implementation of application, it allows you to create an environment, easily create an environment with just the library needed and the tools needed to run your application. And this environment you create with containers can be easily deported to another computer. So that's the benefit of having this lightweight virtualization. So with this kind of virtualization, you can easily create an environment where you can test your application, where you can deploy your application in the process of continuous integration. So this is why containers are highly used in companies every time they want to automate testing of application. So every time they want to automate testing of application, what they do is that they create containers with the environment needed to test the application. And when you want to commit, you take the containers, you apply the modification into the containers, into the application, into the containers, you execute the test, and if the execution in the containers is okay, now you can commit into the main branch of the application. So to give some numbers, today in companies, almost in every companies you will come across containers. They are very popular. Today, everyone is moving to containers. If you want to share your application, if you want to evaluate an application, most of the time you package your application into a container, into these virtual machines, and you can share it by just sharing the container image. For example, if you want to share your application with your friend, you just put this, you create a container in which you put your application, and you just share the image of this container with your friend, and that's it. So today, these are numbers to show you that almost in every companies you come across containers. You have big companies, PayPal, eBay, Spotify, everywhere you have you get in contact with containers because it's a tool that is a lot process of production of producing software, testing software, and also isolating application from different users in the case of the cloud. So when you talk of containers, as I told you, when you talk of virtual machines, you have the image of the virtual machine. In the case of Docker, Docker has a repository where there's images of virtual machine of containers, and you can download these images to use it. So this figure, the first figure, the up left figure, shows you the number of images of virtual machines of containers that are available in the repository with according to the year. So you can see that in 2018, you have something like 37 billions of containers available. That's a lot. This is just to show you that how many, this a number of pools, excuse me, this is the number of pools, a request of downloading images of containers on this repository. So you can see that in 2018, you have 37 billions of pools. That means people downloading images of containers in the repository. So this is just to show how containers are more and more popular, and many servers are running containers workload, containerized workload. So this figure in orange shows you that, so with time, more and more servers in data center host containers. So that means Docker is getting more and more popular. So how does Docker work? So Docker is has a very simple architecture. So it's kind of a client-server architecture. So client send the request to the server, and the server answers it. So Docker is the same. Docker follows the same thing. So in Docker, you have the client, which is the command line you use to interact with the server, the container, which is the virtual machine, the live virtual machine. So and you also have the registry. So let us start with the registry. So the registry, as I told you, you have online, you have a repository where you have images of containers. So in Docker, when you are using Docker, for example, if you want to, for example, to deploy a, if you want to run a Apache 2 in the containers, on the web, you already have a lot of containers, of images of containers with Apache 2 already deploying in it. So you have a repository where many contributors, many people come and put their image of containers for public access, for free access. So what happens is that every time you want to create or to start a container, a live virtual machine, you need to go and see in this registry if there's an image of a containers containing your application you want to run available. So for example, here in this figure, you see there's a registry. It's the Docker Hub. So it is an online registry having a lot of images of containers. You can have images of engines which is a web server. You can have Ubuntu. You can have Redux. You have a lot of images of containers. This is the registry. That means the registry is an online server hosting images of virtual machine. The Docker client is a shell to interact with the server. So it's the command line that you use to interact with the server. Now, the Docker host with the Docker daemon is the central point of Docker architecture. So this one is the software, is the daemon that.
Teacher.
Yes.
Excuse me. We seen screen at slide 1. Is it all right? Or
you are still on slide 1.
Okay. Because
it's not all right. Why didn't you tell me things? Oh, you people, yeah.
Oh my God.
Okay. So you didn't see this slide. Oh, let me.
Okay, now okay.
Why didn't you tell me? Let me.
Yes.
When there's something wrong, just tell me so that I can.
Okay. Thank you.
Let me send you directly the slide.
Yeah.
You send it into the chat. But I'm not,
Yes.
when I'm talking, I don't have access to the chat.
Okay.
Wait a little bit. Let me see. So I send the slide into the chat so you can have it. You can download it.
Yes, yes. Okay.
So here is the figure with where I'm talking of continuous integration. So I see in the process of producing a software, you have to put in place this pipeline where you can test your application. And to have a isolated environment where you can test your application, most of the time you use Docker. So that's the thing. This is the figure where I was talking about numbers. So in the year in 2018, you see that there's something like 37 billion pulls requests for images of containers in the repository in the Docker Hub. So that shows how Docker is now popular in is very used actually. So you have the percentage of um, host or server running on Docker's image. You can see that with time it increases. So here you have the companies that are using Docker. Almost all companies today are using Docker. IT companies, you must use containers because it is a lot of procedure. It allow you to do better and faster some testing procedure of application. So here you have the figure of the architecture of Docker. So the architecture of Docker, you have three parts. You have the client, you have the daemon, and you have the registry. So the registry is an online server in which you have many containers deployed available. So you have many people who created images of containers of light virtual machine and made it available through the repository. So this is an online repository. So that's the thing. So every time you want to use containers or you need the containers to carry some operations, maybe you want to run an Apache 2 server, you most of the time you will get an image already available on the repository hosting the application you want to execute. So what you just need to run these containers is just to download the image on your machine and you can start a container based on this image. We will see that later. So what is important is to don't forget that you have a repository which is known as the Docker Hub that contains image of virtual machines. That's the thing. Now, here to that, you have Docker client. Docker client is a shell. It's a CLE where you it's a shell that you use to interact with the Docker daemon. So the Docker client is a shell that you can use to interact with the Docker. It's a shell that is used to interact with the Docker daemon. That means when you want to interact, you want to send request to Docker daemon, you use the Docker client to address your request. So the Docker client is send the request to the Docker daemon. So it's the Docker host. So the daemon is the heart of the system. This is the software that is used to build the light feature machine, the containers. This is the system that is used to create and destroy the containers or to configure these containers. And what you have to remember is that the Docker daemon also have a local registry. So it is a local registry in which images of virtual machine that you downloaded from the network repository will be stored. So every time you want to start a container, what happens is that you take the client and you say, okay, Docker build. That means I want to build a container. Then you use the Docker client, the Docker client to send the request to the Docker daemon. So the Docker daemon, what it does is that if you want to start a container from an image of the container, the first thing it does is he moves to the registry. To the is he looked into his local registry. Do I have the image of the container you want to start? I mean, imagine you want to build a container, you want to start a container from the image Ubuntu. So what the Docker daemon does is that he looked into his local image. Do I have the image for Ubuntu? if I don't have it, what I will do is that I will connect myself to the Docker Hub, that means the online repository, and download the image of Ubuntu containers into my local registry. And once I download it, I will now start the container from this image. So that's how it works. So the Docker daemon has a local registry where he store the image of container that he downloaded from the online registry. So we are talking about Docker images. So what are Docker images? So as I told you, an image of a virtual machine is the file system of this virtual machine. That means it's a file that contains um, the operating system, the file system, everything related to this virtual machine. So in the case of heavy virtualization and light virtualization, we have image of virtual machine. But light virtual machines are more interesting because the operating system is the image is light. That means when, for example, you yesterday you used Zen and you downloaded an image of a virtual machine, an Ubuntu image, and you configure it to change the password. This is what we did yesterday. So if you remember well. So the interesting difference between a light virtual machine image and a heavy virtual machine image is the size. So a light image of a standard virtual machine, as we did yesterday, can go up to 1, 2, or 5, even 10, 20 gigabytes. But with a light virtual machine by Docker, you have a very small size for the image of the virtual machine. And I will explain it to you later why. So the size of the image of a virtual machine in the case of a heavy virtual machine is much more bigger than the size of the image of a virtual machine in the case of a light virtual machine. So this is because of the representation of the image of the virtual machine. So in the case of Docker, for example, the image of a virtual machine is represented as a set of layers of modifications. So what you just have to keep in mind is that when you start, for example, when you start a container, a light virtual machine, a Docker form, an image, for example, like Ubuntu. When you start it, every time you modify the containers, what happens is that the modification is added to the image of Ubuntu on the image of containers Ubuntu, just like a layer of modification. That means it adds more layer on the basic image that is used to start the containers, and these layers are not very heavy. So by the end, the size when everything is done, the size of the image of a heavy virtual machine is much bigger than the size of a light virtual machine. So using Docker, for example, in terms of size of image of virtual machine is more interesting than using solution like Zen. So also the representation of the image of the light virtual machine. What is interesting is that by having this very light image of virtual machine, this allows easily sharing images of virtual machine. For example, if you have a virtual machine running image of virtual machine on Zen, for example, it can take you something like 5 or 10 gigabytes. I mean, sharing this image to multiple users can be very difficult because it's a huge file, it's very heavy. But when you have light image of virtual machine, just megabytes, it makes it very easy to be able to share it. This is why you have this online repository with images of virtual machines, because it's light. That means to share it is very easy. When you want to download image of a virtual machine with Ubuntu, it takes you something like 10 or 15 seconds. It's very easy. So this is also advantages of using lightweight virtualization. So the last bullet says Docker allows sharing image. So you have Docker Hub, which is the registry, the online repository where images of virtual machines are available. You can connect yourself to this Docker help create your account so that you can come and add your own images of virtual machine. So it's free. You can connect to it. You can download image of virtual machine. You can um, push your own images of virtual machine. So globally, if I want to compare light virtualization with heavy virtualization, this is a nice figure for comparison. So with heavy virtual machines, like we did yesterday with Zen, you have this figure, the left figure, which is which is a representation of a heavy virtual machine. So what you can notice is that with the heavy virtual machine, in the virtual machine, you have an operating system that is running, and on top of this operating system, you have binary and you have applications. So for example, yesterday we downloaded an image of virtual machine with Ubuntu, and in this image of virtual machine, you have another operating system that is running, and on top of this operating system, you have libraries and you have binaries, and on top of that, you have applications running. So with heavy virtual machine, you see there are many layers. You have many layers, software layer, before you reach to the application. So each virtual machine, as it is wrote in the paper, into the document, each virtual machine includes the application, the necessary libraries, binaries and libraries, and the entire operating system. This is the case of heavy virtual machine. But in the case of containers, what is important to notice is that the operating system is shared with all the containers. The right figure. What you can see is that containers, in the green containers, the yellow and the orange containers, they all share the same operating system, which is the operating system directly running on the machine. And now you have the Docker engine, which is the tool that is used to extend to create isolated environment. So the huge difference here is that here all the virtual machines, they share the same operating system, while with heavy virtualization, each virtual machine has its own operating system. So container include the app and all of the dependencies, but share the kernel with other containers. That is the case of containers. With heavy virtualization, each virtual machine has its own operating system. Yes. So, do you have any question? Hello?
Not yet now.
So if you have this in mind, now you start to understand why light containers are faster than virtual machines. In virtual machines, you have double operating system. You have the operating system in the virtual machine, and you have an operating system also that can be running on the load the hypervisor. But with containers, it's the same operating system that is shared among all containers. You see? So when you look at this, you can also understand why virtual machines or containers are faster. So you have less software. If you have less software, that means you are faster. If the less you have a software layer, the faster you are. So this explains why containers are faster than operating system. So when you want to start a container, for example, you don't need to start a new operating system. You use the operating system already running on the machine. But in the case of heavy virtual machine, you have to start a new operating system, and it's in this new operating system, on top of this new operating system, you are going to run the application. But with containers, what you just do is that you just create an environment where you have binary and libraries that is necessary to run your application, and that's enough. So creating a heavy virtual machine takes much more time than creating a lightweight container.
Teacher, I have small question.
Yes, go on.
From with the virtual machine, so which each virtual machine use spread resource. I mean that each virtual machine have the RAM and CPU and no affect to each other.
I didn't get you. Can you repeat, please?
I mean that with the virtual machine from the picture in the lab. So
Yes.
the with the virtual machine it have the allocated will be allocated RAM and CPU and independent with each other, right?
Yes.
Yes. So with the Docker container, yeah, container. So some the application share the using the share operating system and Docker engine. I'm not sure. So it means three the application share the resource. It means the RAM and CPU and something.
Actually, now you asked a good question. This is why it's light virtual machines. As I told you, light virtual machines are less. Um, the protection mechanism is not as strong as heavy virtual machines because they share the same operating system.
Yeah.
You see, the fact that they share the same operating system that makes that the isolation, the security isolation is not the same as when you have heavy virtual machines. So when you use containers, for example, the isolation is implemented by the operating system. So the level of isolation you can have here is very similar to the level of isolation you have with process in the same operating system. It's not as heavy as the isolation you have with a heavy virtual machine. This is why I told you that containers, they are less secure, but they are faster. They are easy to use, they are faster, but they are less secure because they share a lot. That means because each virtual machine, they share the same operating system. If you share the same operating system, that means you have more attack surface. So someone can easily attack you, can more attack you.
Yeah. Okay.
So I just discussed about the Docker architecture. So Docker architecture is quite easy. So you have a physical server, you have the Docker engine, and you have the application. So containers. So the Docker engine is the main part. Is the one who creates the abstraction to create virtual machines. So to do so, as I told you, with kernel level virtualization, the hypervisor is the its operating system is just extended to allow virtualization. So this is the case of Docker. So Docker uses a lot of tools that is available in the kernel to be able to create this isolated environment. So they have tools like namespace of control groups, which are tools that are already available in Linux kernel. And Docker engine, which is the brain of the Docker architecture, just uses this tool to create this environment that are called a light virtual machine that are called containers. So that's it. So to use a Docker is quite easy. You are going to see compared to Zen, it's very easy. It's very easy. It's very light. So the installation is just one line. Installing Zen containers is very straightforward. It's very easy. So you have this line, and that's it. Your container is already Docker engine is already installed. With this simple line, you can install your thing. So now, as I told you, to interact with the engine, you use the Docker client. So the Docker client is a command line that allows you to send requests to the engine. So to interact with the engine, you use the keyword Docker. So the keyword Docker is the keyword that allows you to send requests to the engine. So for example, here is a command line to start a container. So yesterday, you remember the procedure to start a virtual machine, to create a virtual machine was very long. But with Docker, it's very easy. Don't to start a container, you just have to say Docker run. So you say, okay, I'm using the client to send the request run, and I want to start a container from the image Ubuntu. So the image of the container that will be used as base image is Ubuntu, and I want to run in this container this application, which is the batch application. That means the command line. So you have Docker run Ubuntu bash. So this is a basic instruction to start a container in Docker. If you compare this to Zen, you will see that Zen was very long. To start a container with Zen, you had to create image of virtual to start the virtual machine, then create the image of the virtual machine, configure the network, do everything. With Zen, you just do the Docker will configure the networking, everything for you, and you will have a container, a live virtual machine running. So the ITs are just flags to say interactive in French. It means that means I want to be active. I want it to be active so that I can send a request to my container. So when you type this kind of command from the Docker client contact the Docker daemon and say, okay, I have a request for you to create a container from the image Ubuntu, run the application batch in the container. So what the Docker daemon, when he receives this image, does is that he first checks if in his local registry he has the image of Ubuntu. You say, okay, in my local registry, do I have an image of a container for Ubuntu with the name Ubuntu? If he doesn't have it, now he will contact the online repository and try to download the image. So he downloads the image locally, and now he will start the container on the image he downloaded and make it available for the user. So what Docker daemon does is that once he downloaded the thing, he built the Linux, the file system for the container, he start the container and configure the networking of the container. So you have nothing to do. The networking is configured automatically by Docker. So for example, if you want to have the list of images of container that are available locally, you have a set of commands that you can type. Every time you want to interact with the Docker daemon, you first have the keyword Docker. So you type Docker images, and Docker images just gives you the list of images of containers that are available locally. Any excuse me, any question?
Not yet.
So as I told you, in the Docker Hub, you can connect to Docker Hub and create images of your container. You can connect to Docker Hub and track images of container you are interested in. So the first thing you have to get in mind is that Docker Hub is free. You can connect to it and download images of containers. It's really free. You can search images of container on the Docker Hub. For example, to search images of container on the Docker Hub, what you can do is that you do Docker search and you type the name of the image of the container you're looking for. The image of the container you're looking for. So when you type Docker search, you type the name of the image of container you are looking for. That means if you need the image of a container having engines, you just type Docker search engines and you have results. I think I even have. I have Docker installed. So now you can see my tenant. For example, if I do Docker images, okay. You see, you have access to my terminal. So when I say Docker images, these are the local images of container that I have on my machine. You see it?
Yes.
Okay.
Yes.
So now, for example, if I want to start a container, I do Docker run IT Ubuntu bash. For example, now I have my container. So here I was running on my machine. Now I'm in the container. You can see that it changes here. So now I'm a container. So I can say this. This is my container. This is the file system of my container. I can exit from my container. Basic command. You see, it's very easy. Once you have Docker installed, it's very easy. If I'm searching for a container, I can say Docker search, for example, Ubuntu. We will look for Docker image with the keyword Ubuntu on the Docker hub. So now I have a list of containers. If I want to download an image, what I just do is that I do Docker pull and it download the image locally. You see, I'm downloading the image of the container name Smart Entry Ubuntu. Now, if I want, I can run a container based on this image. You see, so it's very easy to use. You can use Docker login to connect it to the Docker hub, but I don't have an account in the Docker hub, so I'm not doing this. You have this. So now, look into the slide, you will see how do you manage creation of images of containers. So you have many ways to create images of containers. As I told you, you can create image of containers and share it. Imagine you implemented an application. As I give you an example, you are implementing an application and you want to share your application with your friend. So most of the time, what you do is that you create an image of containers with your application, and you just share the image of the application to your friend. So to be able to create an image of application is very easy to see. So what you do, you have two ways of doing it. Either you use the commit command line, either you use what we call the Docker file. So let me start with the commit. So let me start. The first thing I will start a container name USTH1 from the image Ubuntu and running the command line bash. Okay, so that's it. Let me open another terminal. So if I do Docker ps, I have the list of container running. So Docker ps is the command line that allows you to have list of container running. So if you look into my Docker ps, you will see that I have a container running and the container name is USTH. This is the container I just started. So here is it, I'm in the container. Yes, I'm in container. So let me move in the container and create a file. Let me create a file. So let me create a file and call it USTH validation. VI. VI is not there. Oh, we don't have VI. Okay, let me install. Okay, so let me do a certificate update and install it. So here I will create a file PSTH validation. I am doing a test. So I created a file in my container. So to create an image of a container, what you can do is that you can use the docker commit command line. So if I do docker ps on my host, I have the list of containers that are running. I can create an image of a container by committing this image, this container is running. It's like in Zen, in Amazon. If you remember on Amazon, when we started the virtual machine, we created an image of virtual machine based on the running virtual machine. So what I do is that I do docker commit and I specify the ID of the container running, and I give a name to my image. Let me call this image PSTH image container. Okay, so there's just one image container. So now I committed the image of my container. So if I do docker image, you will see that there's a new image that was created. Here is it. And this image was created 6 seconds ago, and its size is 168 megabytes. So now if I want to look here, I can start a container from this image. I can say, okay, I want to start a container. Let me call it new USDH container from that. So now if I move to home, you see that I have my file USDH validation. I mean, what I did is that I started a container from an image, a standard image, which is Ubuntu. I modified this container. I use the command commit to create an image with this modification, and now I restarted the containers from this new image that I created. So this is a way to create an image of container. You just do commit. You commit a running container. That means you store a running container, the state of a running container into an image. So all the other way is to use a Docker file. So a Docker file is simple. A Docker file is just a So Docker file is simple. Docker file is just a file containing a set of instructions for creating a Docker containers. For example, here is the content of the Docker file. So let me create to use the Docker file. Every time you use the Docker file, what Docker does is that he will go through the file and he will execute each instruction that is in the file, each instruction in the file, and after he executed each instruction in the file, he will create a container based on this instruction. That means what Docker does is that he starts a container, he executes in this container all the instructions in the Docker file, and at the end, he saves this image, these containers to create an image of container. So let me show you. So let me create a Docker file. So I create a file and I name it Docker file. That's it. So in this file, there is a set of instructions. So I put from Ubuntu. That means I'm going to create this image of container with the base image, which is Ubuntu. I say run apt-get update and apt-get install Apache 2. So that is it. I already created my Docker file. So once that is done, what I do is that I use the command docker build. I specify the name. It's a Docker file USDH, and I specify the path to my Docker file. Yes, no capital letter. You see, now what Docker does is that, he creates a containers. He starts the containers from Ubuntu, which is the base image that's specified. he run each instruction that I specified. That means run apt-get install and apt-get install, apt-get update and apt-get install Apache 2 in this starting container. And when it is done, it now commits the image. So if I do docker image, for example, docker image, you will see that there's a new, where is it? And what how the docker file usth, you have it. Where is it? I didn't create it. Ah, there was an error. So it's Apache 2. So he will redo it. There was an error. Okay. Now he will install Apache 2. Let me see. Working. Yeah. Installing Apache 2 is kind of the next. Let me just see how we install it easier. Installing Vim. That's good. So now he successfully commit. So by using Dockerfile, the commit operation is done directly by Docker. So the Docker. So when I do Docker image, you see there's Dockerfile USA that was created just based on this Dockerfile. So Dockerfile is a way to easily create an image based on the instruction that is specified in the file. So that means if someday you want, for example, to create a container or to share your application with some guy, what you can do is that you can create a Docker file. In a Docker file, you specify all the set of operations to deploy your application. So that means if for example you want to share your application with someone, and in your application you need some libraries, you create a Docker file, and in the Docker file you specify all the instruction that is needed to install these libraries for your application. You do everything that is needed, and you specify everything in the Docker file, and you just share the Docker file with your friend, with someone, and the guy just do Docker build, and he will create the image corresponding to what is needed to run your application. Do you have any questions? Hello? Do you have any question?
What's that?
Is it okay?
I think it's okay.
Okay. So it's quite easy. So Docker, to create an image of containers, you can either start the container, modify the container, and do Docker commit, or you can use the Docker file. That means you have a file in which you specify a set of instructions that will be used to create, that will be executed and after used to create the image of the container. So it's the two way to create an image of the container. So once you created an image of the container, you can push this image of container into the Docker hub and do Docker push. I can do Docker push, and I push this. I can try, but I have to log into the Docker hub, and I didn't. So you can Docker push an image into the repository. It's denied because I don't have an account into Docker hub. You can download an image by doing Docker pull. I can do Docker pull engines, for example. You will download it, or let me see, not engines, Redux is pulling. So I can specify an image of container by using Docker pull. I can download it locally. So if now I do Docker image, you see that there's a Redux image. There is it. I just downloaded it, and it's just 104 megabytes. So the size of a Docker image is much more smaller than the one of a virtual machine. So now you know almost everything about image. So when you start a container, it's possible for you to attach to this container what we call volumes. So volumes are just directory in your local file system. Because containers are virtual machines, so volumes are just a directory in your local file system that you want to mount into the container. So for example, let me do it. It will be very easy. So imagine I want, for example, let me create a directory. Let me call it volume. So here in volume, I create a file, USDH test. I modify the file and I write something. This is on my machine. So this is on the operating system, the basic operating system. So if I want this file to be available into a container, I will use what is called a data volume. So to use it, you use the command, the option -v. So -v is to allow a local directory to be mapped to another directory into the container. So, for example, I run a container based on Ubuntu, for example, and I want to mount my directory volume into my container. I use the option -v. I say, okay, I want the local directory, which is in /tmp/volume, into a directory that will be in the virtual machine that will be /tmp/ let me call it volume underscore container. I run my virtual machine using this. I run my container using this. So now my container now in my container. So now I'm in my container. Now if I move into TMP, you see I have this file. I have this directory containers into my container. You see, and you have the file USH. You see, and here's the content. So if on my server, here is it, I create another file. In my container, I will have this file. So a volume is a way to share a directory between your host and a container. And every time you modify, you add something in this directory, it will directly be visible into the container. I can create something into the directory and it will be available on my host. It is to make visible to one or more container a directory that is from the host file system. You get it?
Yes.
Okay. So a virtual machine, a container is a virtual machine, a live virtual machine. But what you have to, most of the time, a container corresponds to one application. That means if you have a architecture that you want to deploy, for example, you have an architecture with many parts for your application. For example, if you have an application with a database part, a web part, a web application part, most of the time what you do is that you don't put all of this in a container. You have a container for each of the parts of the application. So a container is known to run just one application. Most of the time, a container just runs one application. A container can run more than one, but philosophically, a container is built to run just one application. So that's the idea behind containers. Basically, a container is built to just run one application, so one part of the application. If you want an application having many parts, you should not put all the parts in one container, but each part of the application should run in one container and they should communicate, and you should make these containers communicate. That means if you have a database and this database has to communicate with the web part of the application, the database should run in a container and the web part should run also in a container. So philosophically, that's the way to use containers. So containers are very portable. That means you can move a container from one system to another. You can build your container image and go and execute it in Windows system. You can execute it in Ubuntu distribution of Linux, on Debian distribution on Linux. You can take your container and go running on a Mac operating system. So it's really easy to move the containers from one system to another. It's very easy. This is why it's very interesting to use containers. So today, most of the virtualized environment in the data center, you have a combination of heavy virtualization and light virtualization. So what happens is that most of the cloud providers, what they offer is they use heavy virtual machines to isolate each users, so each client of the cloud. And for a user to isolate application from the same user, they use containers. That means for each user will have a huge virtual machine or a virtual machine allocated for him. And in this virtual machine, he will have containers to separate the application. So in today's cloud computing, most of the time it's a combination of heavy virtual machine and light virtual machine. So in this slide, you have a set of commands that you can use to interact with the Docker daemon. You have Docker run to create virtual machine, Docker PS to list the running virtual machine and the running containers. You have Docker stop to stop the containers. You have Docker kill also to kill, to force the stun of the virtual machine. You have Docker start to start a container that was stopped. You have Docker RM to remove a container. And you have Docker help that gives you every information that is all the operation that you can do. It gives you the help that you can read when you want to do something with containers. Any question? Okay, so now we move to linking containers. So as I told you, when you start a container, you can directly, your containers are created with an IP address. So to allow the communication amongst many containers, you can have many approaches to use. Either you can link them explicitly by using an option when you create the containers. So the option is link, as you can see here on the slide. You can use either the option link, or what you do is that you just ask Docker to create a bridge, a virtual bridge, and in this virtual bridge, you will connect all your containers. So either you explicitly use the option link to connect two containers, or what you do is just that you create a network, a virtual network, and in this virtual network, you connect each of your containers. And each of your containers, your containers will be able to interact. So what you have to remember here is that with containers, you don't have to do the network configuration. Everything is automatic. And this is why Docker lightweight virtualization is very interesting, because Docker, for example, comes with a set of tools that is the manipulation and the handling of containers. You can also implement some port redirection. You can redirect ports every time you receive an instruction for your virtual machine. You can redirect it from a specific port or a specific container. So I will give you the subject of the lab work so that you can practice this kind of thing, because this lab work you can do it at home without any problem. You don't need to have big servers. It's very easy to be able to start working with Docker. Okay, so we have a break for the time for you to, some of you to go back home, and we will continue later. So in 20 minutes.
Yes, okay.
Okay.
Thank you. See you later.
Allô? 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 Okay. I think I will start there because I cannot read no more. I have many things to do. So let me share my screen again. So we need to have the stamina anymore. Okay. Hello? Okay. So as I told you, you can do port redirection. You can do link to link containers. You can do port redirection. I will give you the subject of the lab work related to this, and you can try it. It's very easy. So now we are going to talk a little bit about some tools that are around that are built for Docker environment. So you have tools like Docker machines. So this is a tool that allows you to install Docker on a remote. Oh, my mic is not up. On a remote host. That means this allows to install Docker on a host through the network. So that means you have to administrate a lot of servers. You don't need to go on to move on each server to install Docker. You can use this tool to administrate the Docker installation on host. You have on these servers, you have Docker Compose. Docker Compose is just a script, a file that describes some containers that you want to run. That means if, for example, you want to run 10, 20, or 100 containers, you can use Docker Compose to build a file. And in this file, you just specify which container you want to run. And Docker Compose will allow you to run from this simple file many containers. You have Kitematic, which is a graphical interface that allows you to administrate Docker. That means by using this interface, you can stop containers, start containers. So it's just a graphical interface. And you have what is called Docker Swarm. So Docker Swarm is actually a tool that allows you to orchestrate containers on a cluster. That means with Docker Swarm, you can create containers on a cluster. That means Docker Swarm is a tool that allows you to administrate containers on a cluster. By using Docker Swarm, for example, you can say, okay, I deploy Docker Swarm on my cluster, and each time I want to create a container, I just ask to the master to deploy these containers, and the Docker Swarm will decide on which server he will deploy the containers and do the network configuration that is necessary to make you get access to this container. So let us talk a little bit about Docker Compose. So Docker Compose is a tool that helps you manage multi-containers. So as I told you, you have Docker client. In the basic architecture of Docker, you have Docker client, which helps you manage individual containers. But with Docker Compose, you can manage multiple containers simultaneously. So it works like a front-end script, and this script is then used to execute individually each instruction that is specified to start multiple containers. So Docker Compose, how does it work? So you have a file which is known as a Docker, as a YAM file, and in this file you define and you describe the containers you want to start, and you just do the instruction, or you just use the command Docker Compose up. By specifying Docker Compose up with and specifying the YAM file, what will happen is that Docker will read the YAM file, take the description of the containers you want to start, and execute it automatically, and start all the containers that have been described in the Docker YAM file. So let me do a demonstration. So let me for example create a YAM file so to use Docker Compose. So let me do Docker Compose one YAM. So to create a YAM file is quite easy. So you first have a version, you specify the version of Docker Compose that is used, and in Docker Compose you have the keyword, you have some keyword. It's a YAM file, so you have some keyword. So services represent containers. So here I'm saying I want to deploy a container that will be called here web, and I want you to build this container using the Docker file that is specified in this directory, and the container will be start with this configuration. The port 5000 of the container will be bound to the port 5000 of my local machine, and this container should be linked to another container which is named Redis. And now here I define a container which is Redis, and this container will be start from the image Redis. So with this, I created the Docker Compose file. So in this file, I'm describing two containers. The first one is web, the second one is Redis. The first container, I say, okay, I will build this container from a Docker Compose file, which is in this directory, the local directory. The port, no, let me put image. Let me change this. Let me put Apache. So I will start it from md. So I will so here I specify that I will start two containers. The first one will be called web, the second one will be called Redis. The first container will be based on image Apache 2. And when this container will be started, I want to bind the port 5000 of the container to the port 5000 of my host machine. I want this container to be linked to another container named Redis. Okay, and now the next element here is another container which is Redis, and I want this container to be started based on the image of a container Redis. So when I do Docker Compose up, the YAM file that I've created is now executed. That means so Docker image, Docker search. Let me search for Apache 2. Okay, let me use this one. So let me specify this container. So what I just do, Docker Compose up. So you see Docker Compose up, when I do it, Docker Compose up will create all the container that have been described in the compose file. So Docker Compose is just a service that is available on Docker that allow you to, in one file, describe many containers that will be executed. So you see, now Docker Compose file, he executed the script, and now he started. If I do Docker PS, you see that there you have two containers running. You have one container Redis, and why it's not. It seems like it's attaching volume, creating volume. image edits. Teamwork. So that's the thing. So now if I do Docker test and honestly, so now you can see, yes, there is it. So Docker Compose created two containers. You have the first container which is web and the second which is Redux. So in the file Docker Compose, I say I want to start two containers. The first container will be web, the second will be Redux, and the container web will be based on the basic image Teamwork Apache, and will be linked to the container Redux. So by doing so, Docker Compose created me automatically from just this file, these two containers when I did the Docker hub. So I had these two containers running. You have the web one and the Redux container that was running. So Docker Compose allow you to execute simultaneously from the same file, multiple containers. That's why Docker Compose is interesting. So every time, for example, you have an architecture, to give you an example, if you have an architecture of application that you want to implement using Docker, what you can do is that you can implement everything, you can describe everything in a Docker file. For example, imagine I want to add a MySQL database. I can create a container named MySQL. I call it from MySQL, and I specify port, everything. 32, 46, I don't remember the port. Let me just put it. You can put all the information needed to deploy your architecture, and what you just provide to someone who wants to deploy the same architecture, just Docker Compose file. By having a Docker Compose file, it allows you to easily share your architecture or a implemented architecture with Docker amongst many people. So a Docker Compose file helps you ease the deployment of containers, of many containers. So you have this. So these are the steps. When you do Docker Compose up, it builds image from Docker file, or it pulls image from registry, create and start this container and stream their log. This is their log. These are the logs that were streamed when I did my Docker Compose up. So okay, good. So why is Docker Compose interesting? Because it in the development, because it allow you to have an environment that can be repeatable. That means when you have a Docker Compose file of someone, you can easily reproduce his architecture. You just do Docker Compose up and down it. In the file, everything is already described. It's isolated because it's based on Docker. That means you have virtual machine that contains elements of your application, and it's very fast. It's very easy. You just do Docker Compose up, and the execution is very, very fast. So here you have an example, as I just did, of a Docker Compose file. Good. So after Docker Compose, Docker is mostly used, as I told you, in continuous integration. So in continuous integration, you use Docker to create environment in which your application will go run for testing. So as I described at the beginning of the class, every time you want to put in place a pipeline for evaluating or testing your application, if you are in a development team, what you do is that you take your application and you deploy, or you put your application in the container, and every time you want to test your application or share your application, you just give you just share your containers with each of your collaborators that wants to evaluate your application. So that's it. So I think we talked pretty well about containers. So you have basics information about containers. You have everything. I think you have most of the information about containers. Do you have any questions before I present you a little bit the lab work that you are going to do maybe tomorrow or at home about this? Hello? Hello?
Yes, I'm here.
Do you have any question? Any
No,
question?
I want to do like you, and I think just the question for you later.
Hello? Excuse me, a colleague was handling. Okay, so I saw that there's no question to. Let me just do a quick demonstration of what you can do with Docker. A very fast demonstration. I will not do everything, just to give you a view of what you can do with Docker. Okay. Okay, so let me share. Okay, now I'm sharing your screen. So here is the lab work I prepared for the Docker thing. So it's quite easy. So the lab work was the objective was to deploy. Hello, are you getting me? Okay, it's good. I think my mic is okay. So the lab work, the first step was to connect to a server to install Docker. You see, the installation is just one command. Once you install Docker, the next step was to do basic stuff like creating the first container. The next step is to do basic stuff like creating the hello world container, pull the Ubuntu image from the Docker Hub, list the image of containers, suppress image of containers from the local registry, run these containers, monitor the running containers, you have it there, restart stop containers, attach a console to a running containers, install an application in the containers, create an image on the containers by using commit, stop the containers, remove the containers. The next step will be to use Dockerfile. Create a Dockerfile, build an image of container based on this Dockerfile, or run a container based on this image you just created, and access the application running in the container. Now the last step is to implement an architecture like this. That means you will have a load balancer and you attach to this load balancer two containers. So this is the last step of the lab work. So in this step, the idea was to do what is to use the link between containers to allow a containers running a Asha proxy to be communicating with another containers running Tomcat. So here you have two ways. You can either use a link, as I told you can link two containers, or you can create a network. So in these steps, the idea was to first of all use a link. Yes, the idea was first of all use a link. I think here this configuration. So here the idea was to use a link, and after using the link, rather than using the link, create a network bridge for the containers. Test if the network bridge is working for the containers. And the last step of the lab work is to do a Docker compose file. That means I give you this sample Docker compose file to test how it is working, and after that you modify it to implement your own architecture. So it's a kind of a very easy but long lab work. Hello. So this is the lab work that is related to this Docker thing. Hello? Hello?
Yes.
Okay. So you see, I will send you this file. Let me send it to you now like this. So I just send it into the channel. Either tomorrow we will do it or you can try it at home. It's very easy. It may be long, but it's very easy to do. Okay. So now, I don't think it's even needed to, because I already did all this part during the class. Just read the lab work and try to do it. Tomorrow we maybe do some a little time on it, but it's very simple lab work to learn how to use Docker. So but now let us move to something else. Now we are going to talk about identity access management into the cloud. I think that is very important. When you talk about the cloud, you have to handle identity access management. So okay. Hello, are you still with me or am I alone?
Yes.
Okay. So now we are going to move on something else. We talked about virtualization with heavy virtualization and containers. Now we are going to talk a little bit about identity access management in the cloud. Do you have an idea what is identity access management? Hello? Hello? Okay, someone say yes. So every time today, every time you so every time today I will send you this slide. So every time in our days on any service online, it can be cloud or anything, you have to identify yourself. You have to give your login, you have to give a password to be able to access a service, to be able to access something. You need to identify yourself. So behind this identification, there is some guys that has to manage to handle every user account to make sure that if you are connected, you have access to just what you can access. To make sure that you cannot get access to unauthorized portion of the application. To make sure that you cannot get access to a data that you shouldn't. So identity access management is a set of tools, methodology, process that are put in place to handle user accounts and their access to cloud resources. So when we talk about cloud computing, I, access management is one of the most important things that we have, because in cloud computing, as I said to you during the first time, maybe you don't remember, I said to you that security is one of the main issues in cloud computing. That means people are very reluctant on the fact of moving to cloud computing due to security. And the first way to protect your application or your data when you move to the cloud is by well configuring this identity access management. This is why this is very important when we talk about cloud computing. So You already come across this a little bit during the first lab work with Amazon, because during this first lab work, I created sub account of on my account. So I give you temporary access to my account. This is done by using the IAM system provided by Amazon. So let us start by giving a little bit of context about this. So this is it is kind of very difficult to really give a real definition. I try to give it a real definition, but it's kind of difficult to give a real definition of identity access management. So handling identity access management is kind of not easy, because today in our world you have many different profiles. You have employees, you have supplier, you have partner, you have customer that sometimes has to connect to use the same set of applications which are deployed into the cloud. So you have different um, profiles, different holes that has to connect sometimes to use application or tools that are deployed into the cloud. That means you should put in place, it's important to put in place mechanisms that allow to give access to these different profiles, to these different holes, to the resources that are just needed for them. So identity access management is a set of business process and supporting infrastructure for the creation, maintenance, and use of digital identities. So this is IAM. So it's a set of business process. It is a process. Why is it a process? Because it's something that in the company or as a cloud administrator you have to put in place, you have to implement, you have to define rules of handling user identity, handling user password for the creation and for the maintenance. So that means this identity access management, this process is not just even for the creation. I think there's something even lacking in this definition, because it's not only for the creation, but even for the destruction, for everything that is related to the identity of someone. So it's everything that is put in place to handle identity of users in a, a, a software in the cloud. So identity management is a set of business processes and is supporting infrastructure for the creation, maintenance, and use of digital identity. So, so identity and access management is the process of managing the life cycle of digital identities and access for people, systems, and services. So when you talk about managing people and identity, it includes some things. So the first one is the user management. So you have to manage users who can access the system, who cannot access the system. As a cloud architect or a cloud engineer, you have to be able to configure your cloud space in such a way that you give the right access to the right user. So you have the user management of large changing user population along with delegated and self-service administration. The thing is that when you are in an organization, the position of users evaluates. You can have someone who has you can have an employee that has a promotion. That means he has maybe more rights or more action that can be performed on the application deployed into the cloud, or can access some service also that because he got some promotion. So in the process of IAM, you have to manage this. You have to manage users. You have the access management to allow application to authenticate user and allow access to resources based upon policies. So defining IAM, handling the identity access management is defining policies that give rules of accessing resources. So it's access management. Who has the right to access this? Who has the right to access that? You also have the provision and the provisioning. That means when you create an account, you also have to make sure that if the employee to which the account was assigned is not anymore working in the company, you also have to destroy the account. So the identity access management is not just the creation or the evolution of an account, it's also move on to the destruction of this account. That means if you are the guy responsible for the cloud services or for handling the cloud as a cloud architect, when you define the process of identity access management, you must include the provisioning and the deprovisioning of accounts. you must put in place the process or the policies for creation and destruction of accounts. And also you must put in place software, any technology that is needed to allow to propagate the account amongst many services. We will look at, you will see, we will talk a little bit, we will take more, we will have more information, we will detail more this. We are going to talk about identity provider, but we will see later. So that's the thing. So when you want to implement the identity access management in the cloud, you have many questions to answer. So the first thing you have to, from what I just said, the first thing you have to understand is that when you move to cloud, there's a huge issue of security because you move your software to a provider, to an external provider, to the cloud provider. That means you kind of lose control a little bit on your software. A way to keep a little bit of control and security into your application deployed to the cloud is to handle very well your identity access management. Is to define very strong policies to limit the risk of unauthorized access to your application. And this is done through the IAM. So IAM is very important when you move to the cloud. Being able to make sure that you handle where your credential, you handle where your user account is very important when you move to the cloud. It's the first level, it's the first barrier of security that you can implement easily. So when you want to put in place IAM process, there are several questions that you can ask yourself. So every time you put in place a process for identity management, access management, you can ask yourself questions like, are people what they are, what they say they are? That means this allow you to define which authentication procedure you can put in place. Are they real members of our community? Have they received the necessary authorization? Is respect for their personal data in place? What type of password should I give? What are the authorized activity? What activity are prohibited? To which category of person should this new identity be attached? At what point in the entry process must authorization be given? So there are several questions that you should ask yourself when you want to implement a policy, a strategy of handling user. When you receive a new user, you have a new guy in your company that should use the application that you deploy into the cloud, or that you get access to your cloud, um, to your cloud space. You have to define exactly which are the rules that you want to implement, which are what kind of password this guy can set to his new account, what kind of authorization, what kind of operation this new account can do into your cloud. So everything is handled into the identity access management. So when you talk about the IAM, you have a three elements that you have to take into account. You have the authentication, you have the authorization or the access, and you have the audit. So the authentication, the first part is the authentication. So the first element when you define an IAM is the authentication, to define user and password. Who are you? So you have to define what is the layer, what will be used to authenticate. What am I going to use a password with the username and the password? Am I going to use a multi-factor authentication? Am I going to use, so the first thing is authentication. What is the process of authentication that you have to define? Who are you? The second thing is the authorization. Once you are authenticated, once you have access to the system, what can you do? According to your user account, I must define policies on what you can do. I must define policies on what you can do once you are authenticated. And the last thing is audit. That means after you are authenticated, you did some manipulation. I must have log that allow me to analyze your operation. And in case you try to do something you are not allowed to do, I must put in place mechanism to either alert you not continue to do that, or a reparation to say, okay, this operation was not supposed to do because it was not the guy who's supposed to do this. So you have to put in place audit. That means log analysis to see which operation in your infrastructure, in your application in the cloud has been modified by this. Is this guy having the right to do that and that? So when you talk about identity access management, you have the three points: authentication, you have the authorization, the access, and you have the audit, the monitoring. So these are the three blocks that define on which will be focused most of the activities of the identity access management. So in the authentication, you have the user management, the password management. In the access the access management and the administration and the access management, you have the authorization. And in the identity management, you have account provisioning, account deprovisioning, and no, this is just. So what you have to remember is that you have three blocks on which you define everything. You have the authorization, you have the authentication, and you have the audit administration. So that's the three elements, the base element on which we focus to define a identity access policy. So why is it important? In cloud computing, your data is stored remotely and are accessed over the internet. So this is why the identity access management becomes very important. So identity becomes the most important point of controlling the access. So in the cloud, most of the cloud providers, as we are going to see in the next, allow you to implement your identity access management policy. So you can define policies to access your resources, you can define rules to access your resources, you can define password rules, you can configure identity providers. So identity access management help prevent identity-based attacks and data breaches. I mean, by having a very strong identity management system, you can prevent people from having unauthorized access to your application, to your data, or to your cloud workspace. Hello?
Yes.
Is it good?
Mm.
Okay. So now let us start with the first element, which is the authentication. So authentication is providing a username and a password name. So when you want to when you want to implement a cloud architecture, you want to configure a cloud, you are a cloud architecture, and you have the task of handling the authentication process. So one of the main concepts, the main thing you have to configure is a single sign-on system. So single sign-on system is just a technology that combines several several different application login schemes into one. So imagine now you have many applications that are deployed into the cloud, or you are a customer of many cloud platforms. So with a single sign-on point, you can define a unique point of authentication, and that is very important. It's very easy to use. I'm going to give you a lab work about configuring a single sign-on into Amazon, for example. So with a single sign-on, what happens is that you are capable of defining the entry point for all your applications that are described into the that are available into the cloud, or to all your cloud spaces. That means if you have a cloud workspace in Amazon, you have another one in INP, you have another one in Microsoft, you can configure your single sign-on space, your single sign-on technology. So this will be the unique entry point for all your applications to the cloud. So as you can see in this figure, for example, I have many websites and which represent applications that are deployed to the cloud. I can define a single sign-on point where all the users will connect to get access to the application. So with a single sign-on, it's very interesting because the user just has to just have one link to get access to the whole set of applications. And the thing is that you just have to remember one username and one credential. So once you configure your single sign-on, one authentication allows you to get access to all the cloud applications. So when you are handling identity access management, if you are the cloud architect, always think about a single sign-on point. I mean a single interest point for all the cloud applications. So what is the advantage of having just a single sign-on for authentication? So the first thing is that you can have stronger password. Because today, for example, you have many accounts. You have a Facebook account, you have a Twitter account, you have an Instagram account, you have many accounts. Every time you have to remember all of this, all of the password. If you don't have a tool for handling your password, you have to remember all of these passwords, and that can become very, that you can have too much password. This is why sometimes when you move to some kind of website, because you don't want to bore yourself, keeping in mind remembering a long password, you just type bullshit password. By configuring a single sign-on password, you can, because it's just a single password that allows a user to access multiple applications that you define later. This can make sure that your user will define very strong password, because the user will know that, okay, with just this password, I can maybe access 10 or 20 applications that are deployed from my company to the cloud, for example. So it makes it easier to create and remember strong password, because you have less password to remember, and that's better for the user. The thing is that also you have no repeated password. So when user have a lot of password to remember from different apps, from different services, sometimes you have password fatigue. That means you say, okay, I will use the password. This password, I will just copy paste, copy paste. But by configuring this kind of technology, single sign-on technology, I'm going to give you the lab work where I show you how you can configure the single sign-on technology. By configuring this thing, you just have a single entry point. And in this single entry point, you can access a lot of applications. That means you have less fatigue, and you just have a very difficult password. With a single sign-on, you can define password policy. It means you can say, okay, this password, I want to impose that the password should be a capital L, with this number of letters, with this kind of particular character. So you can also define policies for password. By defining strong policies for password, you kind of increase the protection of your system, of your cloud application. And below that, you also can implement a multi-factor authentication. We will discuss it later. So, and with a single sign-on also, you spend less time for password recovery, because most of the time, for example, for me, due to the fact that you have a lot of accounts everywhere, every time it's password recovery, I'm always going to password recovery, because you always forget password. You always say, okay, I don't remember the password on this website. So, but by configuring this kind of technology, you can have access to multiple passwords. You just have one password, and you don't have to use this password recovery every time. So how does it work? So when you configure a single sign-on to get access to your cloud application, every time a new user wants to get access to your cloud application, the user will type the domain name. That means you get access. You say, okay, for example, I want to access this application using this DNS name provided by you, and the application is deployed to the cloud. When you will type this application, this is one, the user. When you try to access the application will redirect it directly to the single sign-on domain on the website. That means the application will have the single sign-on webpage. So there he will type his password, and the single sign-on now will send the request to an identity provider authentication server. We are going to talk about the identity provider later. So he will send information to the identity provider, and the provider will respond if this guy is really or no, using a protocol that is defined. We are going to talk about it. So when the single sign-on responds to the identity provider, the identity provider responds to the domain, to the cloud application, saying that, okay, this guy actually he's really a guy, and now the cloud application will give you access to the application. But the thing with single sign-on is that once you have the authorization from one domain, you have access to all the domains. That means you can see the line 7, you have it, you can access domain 1, you can access domain 2. So once you are authenticated, you can access all the applications at once. You don't need to authenticate yourself multiple times. Do you get it? So you have one, the user visits the target domain. 2, they are redirected to the single sign-on domain. The user sign in with their credential and the single sign-on domain find a match. So this is 3. That's the thing. And 4, the single sign-on tools request an encrypted token from the authentication server. This is 4. The user is redirected back to the target domain. 6, the encrypted proof that they have been authenticated. And 7, the user can now freely access associated domain 2. The main authentication token standard is called SAML, Security Assertion Markup Language. So security assertion markup language is, let me call it, the protocol that is used for the communication between the single sign-on and the identity provider protocol. So it's this protocol that is used to say, okay, once you send your credential, the single sign-on point will contact the identity provider to say, okay, do you remember, do you have information about this guy? If the guy says yes, now he will respond by giving the token saying that yes, this guy is really a guy, and here's the token of describing his identity. And based on this some assertion, now he can send it to the domain and send it to the domain which requested it, and the user can later on get access to all the application. Hello?
Yes.
Yes.
Do you have any question?
Not yet.
So here I talk about the authentication server. So the authentication server, another name is the identity provider. So you can call it the identity provider. So identity provider, you can consider it as a service that store and manage user digital identity. Have you ever come across any website where when you want to authenticate, you want to authenticate, they just say, do you want to sign in with Google, with Facebook, or with Twitter, like on this picture? Have you ever come across this kind of website? Excuse me. Hello? Hello?
Yes.
Yes, yes. We are still here.
Did you answer? When I ask you a question, you should answer. Just allow me to make sure it's when you answer that I know if you are following me or if I'm talking alone or. So I'm asking you, have you ever come across a website where when you want to authenticate yourself, they say, okay, sign in with Google, sign in with Facebook, sign in with Twitter. Have you ever come across this kind of website?
Yes, we use that a lot.
So what I'm saying is, that is sometimes when you want to connect to a new service, you want to move to a new website, something like that. They say sign in with Google, sign in with Facebook, sign in with Twitter. This is just because Google, Facebook, and Twitter are like identity providers. That means when you say, okay, I want to sign in with Google, what happens is that the website or the service you want to access online, he will contact Google and say, okay, can you give me some information about this guy who say he's a client of Google? Can you give me some input from this guy who's saying he's a client of Google and has an account on me? And God will say, okay, I recognize this guy. He's actually a client. So Google, Facebook, and Twitter act like the identity providers. That means they are system that store identity, digital identity, and manage digital identity of people. So this is why some websites on some website, you don't have to create an account, you don't have to create a password or a username, things like that. You can just say, okay, if you want to authenticate me, ask to Google to authenticate me, ask to Google to give me my identity. So this is why Google, Facebook, Twitter can also act like identity provider. So identity provider is a service that stores and manages user digital identity. So when you configure, as I showed you, when you configure a single site on technology, most of the time you have near to him a identity provider. So when you talk about identity provider, the first thing we should define is what is a identity. So a what is a user identity? A digital user identity is information which are associated with quantifiable factors that can be verified by a computer system. So when you talk about identity, your digital identity is what? It's just information. I mean, that are information that can be verified by a computer system. So when I say identify yourself, when the computer say, okay, what is your password? So these are information that allow the computer to say, okay, I validate that this guy is this guy. So this is your identity. So how do you what kind of identity, what kind of information can we have? We can have knowledge. So this information can be characterized like a knowledge. That means in order to prove your identity, in order to prove that okay, actually I'm who I'm supposed to be, and who I pretend to be, they can ask you this based on your knowledge. So something you know. And this kind of identification is like a username. Example, a username and password. So when you want to authenticate yourself on the system and you specify your username and your password, that means the computer system is comparing your knowledge with what the computer system has. So it's based on your knowledge, the knowledge of the username and the password. It can be also based on the position of something. So if I want to authenticate on the computer, I can say, okay, I possess a key or a phone that proves that I am the one who is trying to connect to the system. So validating an identity can be based on a knowledge or on a position. And the last kind of identity you can use user identity you can use is intrinsic qualities. Now you have something that is particular to you. It can be fingerprint, it can be retina scan. So, so user identity is a set of information that allow you to identify uniquely the user. And this information can be based on the knowledge and the authentication to make sure that the guy trying to access the system based on this identity can be done on the knowledge, that means you know something, can be based on the position of something, or can be intrinsic qualities. I mean, is your fingerprint, your retina scan good, so on. So physical attributes, if I can say like that. So IDP, identity provider, is a tool that allows you to validate that you have the identity you pretend to have. So when you configure your identity provider, you can use one or this factor of identification, or you can use multiple. If you use multiple, we talk about multiple factor authentication. So when you want to connect on a website, sometimes it just asks you your username and your password. That means you are just using one factor of your identity, the knowledge. So you are just testing your knowledge. But we can combine multiple factors. You can say, okay, I ask you this question, and after that you put your fingerprint or something, or your retina scan to make sure that you are. So when you have multiple combination of factors of your identity, we are talking about multi-factor authentication. So to have a more secure system, you have to put in place multi-factor authentication. This is the basic thing. So when you are going to configure a cloud environment or give access to a cloud environment, always think about multi-factor environment authentication. You have to put in place to identify someone. You have to put in place multiple elements to identify the user. So why is identity provider? So identity provider is nice because the identity must be tracked somewhere. You need to have some place where to have information about the identity of someone. It's good to have a provider that is centralized. If you, for example, you are a cloud client, you can implement or you can configure your identity provider that store the identity of all the users that you want to manage. So you have a single point where you manage and you handle all the identity. So cloud services need to know exactly where and how to retrieve and verify user identity. This is why identity provider is important. Record of user identity also need to be stored into a secure fashion to ensure that attacker cannot use them to impersonate user. So when you have an identity provider, you configure your identity provider, you can deploy an identity provider in a secure location in such a way that your identity is secure and someone cannot get access to it and hack you. So this is the thing. You should configure a single sign-on point so that it will facilitate, it will ease the utilization of your service by your client. And also, you should configure a single identity provider that is secure in such a way that attacker cannot use your user account to access your system. So these are basic elements to configure your cloud environment. You must configure a single sign-on point. You must configure an identity provider. So how the identity provider work with single sign-on? So their protocol use is the security assertion markup language. So this is, I can say, the language used by the identity provider and the single sign-on point in order to identify a user. So here is a figure showing the steps of the identification of a user. So the first thing is that the user you first log into an application. That's the one. So when the user log into the application is on the single sign-on point, so it's the SSO. The tool is that the SSO generates a SAML request. So okay, I have this guy who gave me this password and this username. He generates a request and send it to the identity provider in the step 2. Have it here. Step 3. So okay, he make a HTTP request with the SAM request saying, oh, I have this guy providing you this information. Can you state that this guy is really a user? So in for the authentication use server, the IDP generate a response saying, yes, I looked into my identities available, and here's my response. He sent the response file. They said the provider, the single sign-up point now receive the request and decode the request and verify the response. The response. Is this guy saying that is the identity provider stating that this user is really a user of the system? If it's the case, he sent now the answer to the user stating that okay, now you can access the application deploying the cloud. So here you have the process. Any question?
No.
No.
So now you have the step of communication between a single sign-on point and an identity provider. So, as I told you, the best thing, that's what you have to remember. When you are going to configure a cloud account or configure your cloud space, always think about implementing a multi-factor authentication. So a multi-factor authentication or MFA is a way to verify user identity by using more than one factor of identity. It is more secure than the classic username password combination. So that means the user must provide password and username, but you must ask them something. Right? So multi-factor authentication most of the time incorporates a password, you have a username, but it also incorporates another factor of identity. It can be the knowledge or it can be something implicit. The one fingerprint. It can be not knowledge, a proof of position, or it can be implicit. So you must incorporate one or two authentication factors. So when you just have two factors that are used in the authentication process, it's called a two-factor authentication. Hello?
Yes.
Okay, good. So a two-factor authentication. So tomorrow when you are going to use Amazon or you are going to use Google Engine, I don't know. So when you are going to authenticate yourself, when you are going to configure the account, always make sure that you can have multi-factor authentication. That means you can allow user, you must force the user not just to set a username and a password, they need to put their phone number in such a way that every time they want to authenticate, they will be sent, for example, a code on their phone, and they will use this code to prove that they have the position or to prove. So you also, at least you should configure a two-factor authentication. It's the same today. I don't know how it's done in Vietnam. For example, in France, yeah, now every time you want to do a bank transfer, you have to do something related to the bank. You always have a two-factor authentication. It's a must. Every time you want to pay something online, they will always send you a message with a key, with a code, and you have to type it. The minimum two-factor authentication. It's the minimum for security. So with the two-factor authentication, you use the username and the password. They also have it. So most of the time, what it's used is code that's sent to your phone. So it's very popular. I mean, you type your username and your password, and after you receive a code saying, "Okay, can you please type the code?" If someday you create an account at Amazon, you will notice that Amazon asks you to do that. You create the account after they ask you, "Okay, type your phone number so that we send you SMS to verify that you are really a user." So now we are done with the authentication. Now we are going to talk about the authorization and the access control. So what is the access control? The access control is a security term used to refer to a set of policies and restriction access to information, tools, and physical location. So for example, the last time I gave access to my Amazon account, but if you notice, I don't know if you tried, but I when you are so I create you account, but I define policies in such a way that you will just have Amazon. So once the user is authenticated, the action of the user must be limited according to his the access to this resource. And the good thing when you have a good identity access management configure is that if you have the monitoring and the audit is well configured, you will have logs on the tentative access tentative. So when you talk about access control, we have many different access control, many levels of access control. Okay, let me show you a video. You have what is called physical access control. Most of the time, the server that hosts your application are deployed into a cloud infrastructure somewhere in United States or somewhere very far from here. And the cloud provider should make sure that not everyone can have access to this infrastructure. So let me send you a Google link. Let me send you this. Okay. Did you just receive the link I sent you? Someone to speak. Hello?
We are here.
Did you receive the link I just sent you? In the chat. Hello, did you receive the link I just sent you, the video link I just sent you on YouTube? Hello?
Yes.
If no one doesn't answer, we not. Did you receive the link? I'm asking you, see, did you receive the link I sent you? Just now in the chat of Zoom. Give you 3 minutes to watch the video. It's an interesting video talking about the physical security and the access control in data center. Okay. So in this link, you have the access control of physical server in, for example, Google Cloud Platform. So you can see how it's very secure. So it's not a joke. So when we're talking of access control, you can see that each employee has a level of access of authorization. You cannot access this part of the data center. You can access this part of the data center. So this is just to show you how it can. It's very, very, very important to handle access control. It can be software for access control, physical access control. So when we're talking about physical access control, it's a set of policies to control who is granted access to physical location. So who can access the building? Who can access this level? How is the disk stored? How this? So there are many rules that can be defined. Just this is just physical, just to tell you. So now you have information access control. So now these are set of policies that are defined to restrict the access to data and to the software used to manipulate the data. And to implement this, you have many process, you have many models that can be used. So once the authentication is done, authorization can be defined using several approaches. So you can implement what is called a monitoring access control. role-based access control or a discretionary access control. So this is theory. I will go very quickly. So when you talk about mandatory access control, is that you define an access control that is based on strict security policies for individual users. That means for each user, you will list exactly each user which access grant the user has. So for each user, you will define the list of access. That means if you have a if you have you are working in a company, you have to configure the identity access management in this company. If you are using the mandatory access control model, what you have to do is that for each user, you say, okay, this user he can access this other user individually. So these policies are controlled. These policies that define the access grant for each user are controlled by the administrator. So to each individual user are given each access grant. The individual user are not given the authority to set, to alter, or to revoke permission in a way that contradicts existing policies. So that means the administrator is the only one that can define policies. So when you move to highly sensitive organization with highly sensitive data, this is the kind of access control model that are implemented. For example, if you move into the general, that to which they give full access, so to individual elements, they give explicitly access to resources. So by implementing this kind of model, you have a very strong access control. So near to that, you have a role-based control. So in this model, what happens is that you define what I would call groups or roles, and for on each groups and roles, you give permissions, you give grants, and each user will just be assigned to one roles or one group. And when the user is assigned to one roles and one group, he has all the permission that is attached to this group. So this is a role-based access control. So you define groups and you define roles, and to each groups and roles you define permissions and action that can be carried, that can be done. And once you define for a new user, you just assign this new user to this role. So this is the kind of model that you will see in most of the cloud platform that you want to configure. You have a role base. That means when you want to configure your cloud security policies, your access control, you will create for example, developer role. You will create a tester role. You will create this, and to each role you will give access to the resources into your cloud workspace, depending on their activity. So, for example, the tester, if he needs to get access to EC2, you will create a role tester and give the right to execute or to create to access EC2 services in a cloud workspace. So when you define all these rules, when you have a new user, you just have to assign this user to this role. Role-based access control is the most access control that we see into cloud infrastructure. And now the last model is the discretionary access control. So this one is kind of a access control when a user is given the permission to access an object, he can grant access to other users. So if the administrator or the big boss give me access to something, when I have access to something, I can give the same right to others. So it's a discretionary access control. So here you have a figure kind of summarizing everything we did. So mandatory access control is that explicitly for each user, they list the permission that this user can have. With discretionary access control, once the administrator gives you the permission to do something, you can give this permission to another one, and you have role-based access control where you define groups, and to each group you give permissions, and every time a user is part of the group, this user is inherited from all these permissions. So what kind of model do you have to use? If you are in an organization that requires very high level of data confidentiality, like government organization, bank, most of the time it is the mandatory access control that you have to implement. Because if you host very sensitive data, mandatory access control. But if you are in an organization with which needs more flexibility and you don't have to manage access control on very highly sensitive data, you can use role-based permission. Because the mandatory access control is very, very, the flexibility is very, very low because it's the administrator that defines the rules and the access, the permission for each of the users. So every time there's a new user, you have to define rules and permission for this user. So it kind of slow the process. Why with role-based permission, you just, if there is a new user, just assign it to a role and that's it. So now a lot of theory. Now let's move a little bit into practice. So we are going to talk about the identity access management in the case of Amazon. So Amazon provides you a service of identity access management. It's also called IAM. So IAM in Amazon enable you to manage access AWS services and resources securely. So once you have created your Amazon account, or you are created or you are the administrator of the company Amazon account, you have to configure the access management. So in Amazon, access management is a role-based access management. So in Amazon IAM, AWS, Amazon Web Services IAM, you have a set of roles, let me call it. You have a set of components. You have the user, you have the group, you have the role, and you have the policies. That are the components to define identity access management in Amazon. So what is the user? Do you have any question? Hello? Any question?
No, not yet.
No.
Okay. So so when you start, we start by the user. So the user is a user, as it's stated, there's no other word, and the user can have a username, a password, and the user is the one who use this username and password to access the console, the portal. For example, I created user for you to do the laptop. So a user can generate what we call credentials. So credentials are a set of alphanumeric code that can be used to automate your interaction with the cloud platform. For example, I can generate credentials I can generate credentials. For example, let me show you how I will suppress this credential. So for example, let me show you some credentials. For example, here you have, for example, here, so that I will suppress the credentials, that means there's no problem. For example, here, you have some credentials that are generated to get access to my Amazon account. So these are credentials. You get it? So these are credentials. So credentials, let me see. So credentials are a set of tools as credential are set of tools. Credential no, not set of tools. Credential are alphanumeric characters that can be used to automate your connection to cloud platform. For example, I use this credential in order to automate the creation of user profile. So I have a script that interact directly with Amazon services. So you generate a credential to allow you to get access to your services from the API, from the normal Python or Java code source. But something that you have to answer, never put your credential into a Git repository. That means if you are implementing a project for the cloud and you have credentials that should be used to deploy your project into the cloud, never put your credential into a file, into a code source like this, like I did, and push it into a Git. Never do that. Never. Okay. So you can generate a credential for a user to allow it to get access to your services. So when you create a user, you have to give permission to your users in order to do anything. So that means if I'm the administrator, I have the root account. Every time I create a user, the user has the right to do nothing. So once a user is created on Amazon, that means if for my account, for example, when I created user for you to do the lab work, if I don't explicitly grant you access to some services of Amazon, you cannot do nothing. So once I created once a user is created, you have to give you have to assign this user to a group for this user to have permission to do something. Okay, so that's it. Now you have groups. So groups is a collection of users. So when you want to configure your identity access management system, you have to to create groups, and for each group you have to assign users. Now to each group you have to link this group with you have to define policies or permission to each group, and each user should be assigned on one group according to his profile, according to what the user is supposed to do. So for example, if I'm a developer, I should be in the developer group. If I'm a tester, I need to be into the test group. And once I'm in the test group, in a group you just have permission to access the resources that are needed to do the test, that are needed to do the development. So this is on Amazon. And you have now the roles. So roles are very similar to groups. So that are profiles that to which you granted some permission to do something. So roles are used to create and manage AWS users and their permission to allow and deny their access to AWS resources. So look at roles as when you want to do something. When you want to do something, to do something, you want to do a specific operation on your AWS account, you can get a role, and on this role, that means it's kind of having a casket, in fact they call it casket, a hat, and this hat represents a role, and with this role you have a specific permission that allow you to do things. So roles are kind of groups, not groups, but they are kind of position that you can get because you want to do some operation. So I can take a role of tester because by taking a role of tester, it allows me to do this operation as a tester. So you have group and you have role. So on Amazon, you can configure groups, you can configure role, and you can configure policy. So policy are now the rules that are used to limit the operation of a user. So when you create a group, you have to associate to this group policy. And in this policy, you specify the permission that you want to grant. That means, oh, I want this user to do this. I want this user to do this. I want this group to get the right to do this. So you define policies that are linked to this group. So identity access management in Amazon can be implemented using a JSON format. But you also have a graphical interface to do it. So identity policies can be implemented using a JSON format. we talked a lot about identity access management. Now let us give some best practice. So what should you do when you are in your company and you want to configure it? So what are the best practices? So first thing, once you are connected, once you created your account, protect your root account. Never use your root account. So once you are created, always create a sub account that is under your root account and to do daily administrative tasks. Never work on your root account. It's like if you have a system, you don't do sudo every time. So you always have to protect your root account because you can have bad manipulation, you can do stupid things. Another thing, you have to create individual users. Don't create a script that will create new users. Because if you do such thing, you will now have control over the user and their permission. Create individual users. You should use groups, and for each group assign policy. When you move into a company and you have to manage the cloud infrastructure, if you are using Amazon, the first thing is that if you have to manage the identity access management, you have to define groups according to the company, according to the different position of people in the company, and to each group you have to define policy. You have to set up strong password policy. That means when someone wants to access, you want to create an account to some new employee, you have to say, okay, I want you to have a password or something like 8 or 9 words, to have a capital letter, to have digital numbers, you have something. You have to have a very user platform authentication, a multi-factor authentication. So you need to define at least two-factor authentication. Every time you want to access your system, you need to type the password or username and also use another authentication factor. So you can also use roles or instance defined. So if someone want to carry on some operation, you can define roles that can be used. You should put in place rotation of credentials. So that means if, for example, you are automating some operation, you generate the credential, you should put in place policy for automatically generate new credential very often. Because if you use a credential, someone can get your credential and therefore can access your service. You also have to put in place monitoring services. For example, with Amazon Access Management, you can, with Amazon IAM, you can monitor the activity of users. So you have to put in place a monitoring system for IAM activity. You must protect your root account. So that's the first thing. So the root account in AWS has full access to any services. So you must make sure that you protect it. You create new by design, its permission cannot be restricted. So never work on root account and never create credentials for the root account. Create a sub account under the root account and use it. You must create individual IAM user. Each user gets her account. So each user can get its own account. You must not have use an account for multiple users. This allows managing the user very easy. You should think about creating user groups. That means you should create groups to have allow you to have a logical defined set of users. To create groups, and to each group you assign policy, different policies. Group can have different set of policies. You should think about it when you want to configure your identity access management. Another thing is that the user can be part of multiple groups. You can be a guy which is a developer and a tester. You can be a guy which is working in section A and working in section B. So it's possible. So when you define well your group, you can now assign a user to multiple groups according to the user profile. You should define a set. You can set up a strong password policy. Users should have permission to manage their own password, but there should be a very strong policy, a minimum length, complexity, periodicity, rotation. You should configure your system in such a way that every 1 month, every 2 months, every 1 week, the password should be changed. This is good habit for security when you want to configure a cloud environment. You should use multi-factor authentication. So multi-factor authentication allow you to use multiple factors to authenticate a user identity. In addition of using the user and password and name, you can also have you can set other elements for second factor authentication. A phone number, a phone call, a phone code, a code sent to the phone. I'm not sure that fingerprint can have it, but you should really think about having multiple factor authentication. So you should define goals. So if you have an app or a script that needs to make an API call on your services, you can use this call to realize operation. And the good things about goals is that the credentials expire very automatically expired by Amazon. So you should define rules that allow you to automate some operation using the API call. Amazon. You have to rotate credential often. So you must enforce all the keys and passwords to be changed often. The password should be changed once in 90 days. So when you generate keys, you should set the possibility for some keys to generate another set of keys to generate the old one. So that means you must put in place a rotation process in such a way that keys that are used will not be reused, and also to make sure that very often the key change. And the last thing, the good habit is to monitor the activity. So AWS gives you logs of all access policy operations. So you have to put in place mechanism to monitor this access operation to detect if there's any unauthorized access, if there's any bad access. So you must use services like Cloudtrail log or S3 to store um, these logs and analyze them to see if there's any unauthorized access and to set up alert on any interesting activity. Hello? So that's it. Identity access management in the cloud. Do you have any question?
Not yet.
When you say not yet, it seems like you are going to have a question very soon. But
We will have we will have questions when we actually do the task.
okay, 1 minute. Okay, so let me authenticate on my cloud, my Amazon account, and show you things. You have no question. No question at all. Nothing. Hello?
Yeah.
You have no question. No, nothing.
Can you send us the lecture slide so that we can look at it again?
Yes, I will send you the lecture file.
Okay, thank you.
Lisa, you have no question. Okay. So let me share again my screen. Okay, here you have my Amazon account. So you can have IAM. Here is the Identity Access Management Services in Amazon. Here you have it. You see, here are the users created for you. You see user 1, user 10, user 11, all of this. These are the users. And for each user, I give you full access to Amazon EC2. That's the only access you have. This is because I put you in a group that is called USTH. You see, I created the groups. So here you have the groups. You have the groups. And in this group, I define the policy. So here you can select this group. These are the permission that I give access the policy. You see, so I can attach policies. I can say, okay, in this group, I want to attach policy. I can select one of these policies. They already predefined policy. I can attach one. I can select, okay, I will have this and attach a policy. It's quite easy. It's very easy to have this. Attach policy is very easy. So it's very easy. So you have it, you can define. It's easy when I'm explaining because you can have very complicated policy. So I can move in the groups. Yes, here are my groups. I have this, and I can say user, and can say you remove user from group, and I select remove users. That means I still have the users, but they are not in my group. You can define goals. These are basic goals that are defined. These are policies that are assigned to each role. So you can write a script that is based on this role to do some specific or temporary operation on Amazon. You can define roles. Here is policy. And now you have identity provider. You can configure an identity provider to get access to your Amazon account. I'm going to share with you, maybe not today, but tomorrow, the lab work that you can do to implement this. So you can implement a single sign-on. You see, Amazon is saying, okay, you try to use my single sign-on point. You can use Amazon services or you can use an external one. The lab work I'm going to give you is a lab work where you use the external identity provider and the external single sign-on provider. You see, so these are the basics elements to implement identity access management. You define roles, you define policies, you can configure identity provider, and yes, account settings. So now it's my account settings. Change password policy. See, I can define the password policy. I say, okay, require at least one uppercase. So you need to define very strong password policy. It depends now on how. Require at least one uppercase, require at least one lowercase, require. This is to force people to set very strong password. You have service like Access Analyzer. So you can implement an access, you can create an analyzer, and that will define that will react when there's something and take action. So you can monitor, you can define operation that can happen or activities that are suspect and take action when these activities are realized. I will not do it because it will cost me money. It's my account, it's my bank account. So here you have it. So here you have the identity access management. So this is on Amazon, but you can have it. You have it on any cloud, all the cloud providers. So when you want to manage a cloud application, you want to manage. You are a cloud engineer in a company, and you are responsible of handling the identity of users. You just move into the identity access management, and you configure everything. Hello?
Yes.
Yes.
Now that you saw how things work, do you have any question? No question? You have no question?
We don't have question right now, but I think later we will have a lot of questions because we don't know what to ask about yet.
You should be to ask me a lot of questions. Let me send you the slide of the class. This, that you can use it. Okay, let me send you the slide. Okay, now you can download the slides of the class. Okay, so what are they? So you have this little lecturer. I'm going to present it tomorrow. I'm not sure that you have time to do it, to configure an identity provider with Jump Cloud. So the idea of identity Jump Cloud is to have a single sign-on point. So here you use Jump Cloud as a single sign-up point and the identity provider for Amazon. So the step here is to configure it to have a single point where you can access Amazon resources. So it's a set of slides where I give steps to configure it. You configure it. After by the end you have this kind of interface. And when you single sign on, when you click here, you have access to Amazon with a limited set of authorization. So tomorrow I'm going to send you this. I hope we will be able to maybe do this because it's quite interesting. So I think we are going to stop it for today like this. Hello? Hello?
Yes, we hear.
Okay, so we are going to stop now. Tomorrow we will continue. So you have this, and we are going to look a little bit on the IDP on top software to manage the private cloud. We're going to do that tomorrow. So tomorrow is going to be a lot of talking again. So see you tomorrow
Okay.
then.
Okay, we will review the slide, and then maybe we will have question tomorrow.
Okay.
Okay, thank you.
Thank you. See you tomorrow.
See you.
See you.